Today I'm going to show you the principles of a back titration. A back titration is really just a more complex version of an ordinary titration, but once you understand the concept, it becomes very easy. So basically, use a back titration when you have when the substance you're titrating is solid. So solid substance. You also use back titration when the substance you are titrating is volatile. So like ammonia. An example of a solid substance can be calcium carbonate. You will also use back titration when the reaction progress is very slow between the acid and the base. So the reaction progress is very slow. And lastly, you'd use it in the case where your endpoint is not very clear. So unclear. So how does back titration really work? Let's just take an example. So let's just say you have a relatively weak base that is volatile. So let's say ammonia. And you titrate this with a strong acid. So ordinarily you titrate ammonia with a strong acid because for a clearer endpoint, but because ammonia is volatile, you wouldn't want to really perform it because some of the ammonia may not react with the strong acid. Okay, so let's say for this example, hydrochloric acid. So what you do is you do a back titration in that case. In a back titration, basically you would add excess of the strong acid in this example into the aqueous ammonia, and what you get from this is basically a salt, and you'd also have the leftover acid. So the leftover acid. Okay, so what you'll have after you react the excess hydrochloric acid with the ammonia, you'd have the leftover hydrochloric acid, and you'll have the salt, which is the acid that reacted with the ammonia. What you now want to do with this is actually titrate the leftover acid with not HCl but a strong base. So it could be sodium hydroxide, or it can even be something like sodium carbonate. So you don't want to titrate the HCl leftover with a strong base. So what you'd have after this is you'd have the volume, like a normal titration, you'd have the volume of strong base required. So you have the volume of strong base required to completely neutralize the leftover acid. Now, using this information, because this is a standard solution, meaning you know the concentration, you can now find the moles of the strong base and therefore the moles of the leftover acid. So after you titrate the excess acid left with the strong base, you would, using this information, you will calculate the moles of the strong base, and using stoichiometry you calculate the moles of the strong acid. So remember, this is the moles of the strong acid left over. Now, because you know the moles of strong acid left over, and also I forgot to tell you this, but the strong acid you use in excess is in a known volume. So known volume and also it is a standard solution. So therefore you can use this to calculate the moles. You can use this to calculate the moles initially. So now you see where I'm headed with this. You have the moles of strong acid left over using the volume of strong acid you used initially, the excess, and because it's a standard solution, you know the concentration. By finding the difference, you would basically know the moles of the strong acid which reacted with the, in this case, ammonia. So like I said initially, the you have the moles of acid. This is a strong acid initially. Then you can subtract this from the moles of acid left over. When you find the difference of this is basically the moles of acid which reacted with, in this case, the ammonia. So it's pretty simple from here. Now that you have the moles of acid which reacted with the ammonia, you can get based on the equation with ammonia and the HCl. In this case is a 1-to-1 ratio. You can get that will be equivalent to the moles of the ammonia. And because you have a known volume of ammonia you used, so known volume, remember it's a concentration you do not know, that's why you will perform a titration. So you have a known volume of the ammonia. You can now get the concentration because you have the moles of ammonia, and then you have the known volume. You can get the concentration by dividing the moles by the volume. So it's pretty simple. So now I'll show you just a simple example of a back titration. Relatively simple example of a back titration. This basically says that a solution containing 45.0 cm cube of a 0.200 mole per dm cube solution of HCl is added to an unknown concentration of 20.0 cm cube sample of ammonia in excess, hydrochloric acid in excess. The hydrochloric acid in excess is then titrated with 0.0500 mole per dm cube aqueous solution of sodium carbonate, and it required 27.5 cm cube of sodium carbonate in order to neutralize the hydrochloric acid. Using this information, calculate the concentration of ammonia. So this example is relatively straightforward, and I'm going to show you basically how to do it and the steps required based on what I showed earlier. Okay, so you have the volume and the concentration of the hydrochloric acid. But first off, you can get the moles of the hydrochloric acid. So you already know that's you just have to convert this in. That's what I'm doing here. I'm converting this into dm cube. You should probably put units when you're doing this, but yeah. So you have 2.0 mole per dm cube, and from my calculations, that is equal to 0.00900 mole. That's of HCl initial. So HCl initial. So you have to remember, this is the initial amount of HCl, not the leftover. Now we have to get the leftover amount of HCl. So firstly, what we want to do is they give us the concentration of the sodium carbonate required, so we can get the moles of sodium carbonate. So that's what we should probably do first. Get the moles of the sodium carbonate. They gave us 27.5 cm cube, and so we just do the same thing for here. So that this one is like I said, you probably should write units for this. What it was, okay, 500. So from my calculations, this is equal to 0.00138. Okay, so using this information now, we need to first get the reaction. So basically the stoichiometric ratio between this and the HCl, because remember, you're reacting the HCl with the excess HCl with the sodium carbonate, because you want to get the leftover. We already calculated the initial. You want to get the leftover hydrochloric acid. What you want to do is you want to write down your reaction between HCl and sodium carbonate. For you to get the, remember, what you want to calculate is the leftover HCl in this, because you have the initial, you want to get the leftover hydrochloric acid for you to get the moles of ammonia. So what I did was I basically wrote down the reaction between the equation for the reaction between the hydrochloric acid and the sodium carbonate. So as you can see, I wrote it down already, and I balance it. When you do this, write the state symbols. So as you can see, the ratio between hydrochloric acid and sodium carbonate is 1:2. So what you would want to do is multiply the moles of sodium carbonate you got here by 2 to get the moles of hydrochloric acid, what you do in a standard titration. So you'd want to multiply this. So let's just say that's HCl left. The HCl left, you would multiply the moles. So this is moles times 2, and I calculated that to be 0.0275 mole. Okay, so once you do this, you have to get the, like, you have the moles of HCl left, and then you have the moles of HCl initially. So now you can get the moles which reacted with the ammonia. So that's quite simple. All you have to do is find the difference between the initial and the final. So the initial and the final. So just subtract these two values. And subtracting these two values, you get an answer. I believe it's 0.0625 moles of hydrochloric acid which actually reacted with the ammonia. So you can write down the equation for the reaction between hydrochloric acid and ammonia. So this is AQ goes to give, so this is ammonium chloride. As you can see though, the ratio is actually, so the ratio is actually a 1-to-1 ratio, so we don't really have to do anything. If this was it required 2 lots of this to neutralize the ammonia, then you'd have to multiply it by 2. The concentration of the ammonia, all you basically do is, as you know, concentration is moles divided by the volume. So basically let's just put the moles here first. Remember, the moles we got was 0.00625 moles, and that divided by the volume, I believe this was the volume, you get 0.03 mole per dm3. And simple as that, that's how you do a back titration problem. If I forgot anything, then you're welcome to suggest it in the comments below.